Welcome to the office. We want to take a look at generating sets today. So for generating sets, this really isn't much different than using an element to generate a subgroup of a group. Really, the only difference is that instead of taking a look at one particular element, we're taking a look at two or more elements, right? So we're going to take those two or more elements, not only raise them individually to powers, but we're going to also take their product and raise the product to powers. So when you have commutativity, then it's just, A times B to various powers. But when you don't have commutativity, then it could be A, B, A, B, A, B, A, B. It could be any finite sequence of the elements A and B, products or additions, whatever the set operation is or group operation is. So let's take a look. Let's write some stuff down. So some notes here a moment. Last time that we got together, we were talking about, so in section 6 there, we were talking about subgroups and cyclic groups rather. So we're talking about cyclic groups, and we talked about Z12. And we said that Z12 was generated by 1, for example, but we also had subgroups that were generated by, let's go 2 and 3. Let's just to take a couple of examples here. 2 generated the subgroup, which contains 0, 2, 4, 6, 8, 10, and 12. Right. I think I forgot the 10 last time or something of that silly sort. Anyway, it generates all of these elements. Of course, when I add these together, I get more elements within this set because we're working modulo 12 here, not 12. The set generated by 3 includes 0, 3, 6, 9. Oh gosh, I don't want 12 there. That was silly of me. There we go. 3, 6, 9. That looks good. So I have my 2 subgroups here that I have generated. 2 generated the first here, 3 generated the second. And what I could do is I could notice that if I take what's generated by 2 and 3, for example, let's see here. I want to make sure that this notation matches what's expected here for notation or generation. I'm not sure that they actually use this notation in this textbook. Rather, they say what's generated, the subset generated by the set 2, 3. And really what we're looking at there is, since we're working in addition, we could call this A times 2 plus B times 3, such that A and B are integers. Okay. So this is any linear combination that we can create. Well, in this case, it's actually, this is correct because we have commutativity, but in general, and maybe that's not what we want for in general. In this case, it is. That's fine, actually. In general, it is any sequence of additions of 2 and 3. So we should see a better definition of what the subgroup is generated by this in this section yet. But if I wanted to take a look at those things, of course, what I should recognize is that I have 2, 0, of course, 0, 2, 4, 6, 8, 10, all of the things that I can generate from just 2, as well as all the things that I can generate from just 3. 0 and 6 are already there, so I'm adding 3 and 9. But I can also create, for example, 2 plus -1 times 3. So I can add the inverse because we're closed with respect to inverses. So I could do 2 plus the inverse of 3 is 9. So I could do 2 plus 9, and that's 11. For example, I can create, if I can create 11, then 11 plus 2 gives me 13, which is 1. I already have 3 in there. I can get 5 now by adding 2 and 3 together individually. 7 I can get because I can take 2 times 2 plus 3. Let's see here. What else am I missing? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I can take, oh no, I have 10 there. 8, 9, 10, 11. Hey, everything's there. Everything's there. All right, so that is all of Z12. So that's generated entirely by these 2 elements. So I have the 2, I have this, and then the only other things that we're interested in looking at are intersections. So if I wanted to take the intersection to intersect with 3, of course, you'll notice that is the elements 0 and 6, which is itself a subgroup. We said that that was generated by 6 itself. So we have a way of generating subgroups using multiple elements rather than just one element. That's what we're doing here. We have ways of taking intersections of subgroups, which is going to give us also a new subgroup, which of course, since this is cyclic, we're going to have it, that it is cyclic, right? Z12 is cyclic, so all of its subgroups are cyclic. And that's really just the kind of the big idea of the section. Generating sets. We can use a set to generate things. And of course, if I were to look at a larger example, I don't know, Z24 maybe, I could look at a couple of different subgroups or a couple of different numbers here that would give us almost everything, but not actually everything. Okay, so generating a new subgroup that isn't the entire group. All right, that's essentially what we want for now. Technically, with what your homework is, you should actually already be able to respond to your homework problem because, if I assigned a number 1, then we need to pick a new homework problem because that's what I just did. So maybe we'll pick 3 if that wasn't that's not already the one that's assigned. But you should be able to approach the homework problem. Everything else that remains for this section is just some notational concerns and a few details that we want to pick up as we prepare to move forward with groups, our theory on groups. So they won't be addressed specifically or explicitly on the homework for the section, but we will use the ideas a little bit later in the course. So join me for the remaining videos on this section, and we'll pick up a couple of details. I'll see you in a little bit.